Today, we are building something very important. We are connecting grade 10, grade 11, and grade 12 into one understanding. Let us start with the basics. In grade 10, you learned about scalars and vectors. Scalars are quantities with magnitude only. Vectors are quantities with magnitude and direction. For example, mass is a scalar, distance is a scalar, force is a vector, displacement is a vector, velocity is a vector. Watch a grade 10 video for more information. In grade 10, you also learned about motion in one dimension. This means motion along a straight line. Only one variable changes. If the motion is horizontal, then only the x direction changes. For example, a man pushes a box with a force of 120 N eastwards on a straight horizontal surface. When we draw that force on a Cartesian plane, we use an arrow. The arrow tells us two things. The length represents the magnitude. The arrowhead shows the direction. So if we draw an arrow from point A to point B, pointing to the right, that is a one-dimensional vector because only the x direction changes. You can also have one-dimensional motion in the vertical direction only. For example, a ball thrown straight up, an object falling straight down, that is still one-dimensional because only one direction is changing. Now in grade 11, we move to two dimensions. This means motion happens in both the x direction and y direction. For example, when a man pushes a box up an incline, the force is no longer purely horizontal. For has a horizontal influence and a vertical influence. So this vector acts in two dimensions. That is why in grade 11 we begin to talk about resultant vectors and resolving vectors into components. Before we resolve any two-dimensional vector, we must understand the idea of a resultant vector. Suppose one vector acts in one direction and another vector acts in another direction. When their effects are combined, they produce one new vector. That new vector is called the resultant vector. A resultant vector is the vector sum of two or more vectors. That is, a single vector having the same effect as two or more vectors acting together. That word sum is very important. Do not leave it out in the exam because it shows that the vectors are being combined into one. Imagine that from your door, you first walk 10 meters to the east, then 7 meters to the north. You still end up at the plant. Now suppose instead of walking in those two separate paths, you walk straight from the door to the plant. That straight path is the resultant displacement. Why? Because it has the same effect as the two separate displacements combined. That is exactly what a resultant is. One vector that has the same effect as two or more vectors together. Two people pulling a box. The woman pulls the box in one direction and the man pulls it in another direction. When they pull at the same time, the box will move to this direction that is a combination of both pulls. That green arrow represents the resultant force. If we remove the woman's force and the man's force and keep only the green arrow, that green arrow summarizes the total effect of both forces. That is the resultant. Now, let's focus on how we determine the resultant of vectors. The first thing we do is break each vector into two parts, a horizontal component and a vertical component. Once we have done that for all the vectors, we then add all the horizontal components together to get Rx, which is the horizontal component of our resultant that we are determining. And then we add all the vertical components together to get Ry, which is the vertical component of the resultant vectors that we are determining. These two, Rx and Ry, will help us find the resultant vector. Thereafter, we use the Pythagorean theorem to calculate the hypotenuse, which will be our resultant vector. That's easy, right? Let's look at this example here. Two boys are trying to pull a tree stump out of the ground. One boy applies a force of 300 newtons and the other boy applies a force of 450 newtons at 50 degrees to the 300 newtons force. Here is the diagram that visualizes that. Let me start with the first force, which is 300 newtons. I will draw it separately so that we can clearly see its components. This force is given at a bearing of 60 degrees, so I need to understand its direction relative to the horizontal axis. Once I know the angle, I can resolve it into components. Now, the force is given at a bearing of 60 degrees. Bearings are measured clockwise from the north direction, which is the upward vertical axis. In this case, we have a force F, one of 300 newtons at a bearing of 60 degrees, which means that this particular force is acting in a direction that makes an angle of 60 degrees measured from the vertical y-axis. Our goal here is to get the angle that is formed by this vector with the horizontal x-axis, bearing in mind that from the positive axis we have 0 degrees, and the upward vertical axis forms a 90-degree angle with the horizontal. We know that going from 0 degrees to the vertical axis we have 90 degrees in total. So subtracting 60 degrees from 90 degrees, we get 30 degrees. So this means that the angle of this vector with the horizontal is 30 degrees. Now we are going to calculate the components of this vector. First, we will determine the horizontal component. According to the trigonometric definitions, this is the adjacent side of the triangle. By definition, cosine theta is equal to x divided by r, where r is the hypotenuse side of the triangle, and that is our F1 force that we are breaking down. Our angle is 30 degrees, so we have cosine 30 degrees is equal to F1x divided by 300. If we make F1x the subject of the formula, we get F1x is equal to 300 multiplied by cosine 30 degrees. My calculator gives me 259.8 newtons east, and that is the horizontal component. Now let's determine the vertical component. In this diagram, the vertical component is the opposite side of the angle, and we are going to determine it using sine theta. By definition, sine theta is equal to y divided by r. So we have sine 30 degrees is equal to F1y divided by 300. If we make F1y the subject of the formula, we get F1y is equal to 300 multiplied by sine 30 degrees. If we calculate that, we get 150 newtons towards the north direction. Now let's proceed to the next vector. Our second vector F2 is 450 newtons. For this vector as well, we need to find the angle it makes with the horizontal x-axis. We can determine this angle using its relationship with the first vector. We are given that the second vector makes an angle of 50 degrees with the first vector. The first vector is 30 degrees away from the horizontal axis, which makes the second vector 20 degrees away from the x-axis. Another way would be by using the bearing. We are given that this force is at a bearing of 110 degrees. Since the angle from the vertical axis to the horizontal axis is 90 degrees, subtracting 90 degrees from 110 degrees gives 20 degrees. So in either way, we get 20 degrees as the angle from the axis to the F2 force. Now we will follow the same procedure to calculate the x component and the y component of F2. We begin with the horizontal component, which is the adjacent side of the triangle. Cosine 20 degrees is equal to F2x divided by 450. Making F2x the subject of the formula, we get F2x is equal to 450 multiplied by cosine 20 degrees. That gives me 422.86 newtons. For the y component, sine 20 degrees is equal to f2y divided by 450. Making f2y the subject of the formula, we get f2y is equal to 450 multiplied by sine 20 degrees. That gives me 153.91 newtons. Now that we have done that, we proceed to combine these components. According to the rule, we add all horizontal components to find fx and all vertical components to find fy. From F1, the horizontal component was 259.8 newtons and the vertical component was 150 newtons. From F2, the horizontal component was 422.8 newtons and the vertical component was 153.91 newtons. Now be careful with this one because it is pointing in the negative direction. If our resultant is f, then fx is equal to f1x plus f2x, which is 259.8 plus 422.86. That gives me 682.67 newtons. Now Fy is equal to F1y plus F2y, which is 150 plus negative 153.91. That gives me negative 3.91 newtons. Now let's determine the resultant. According to the diagram, our resultant force is the hypotenuse, so we apply the Pythagorean theorem. We have Fx squared plus Fy squared is equal to F squared. Substituting the values, we have 682.67 squared plus negative 3.9 squared. To find f, we take the square root of both sides. This gives us f is equal to 682.68 newtons. Our resultant is equal to our fx, which means our resultant lies along the x-axis. If we draw it in the diagram, it will look something like this. We will continue this tutorial in the next video.